Good morning. Good morning, everyone. Thank you for coming. We are going to speak about refactoring. And when I came with this idea for the talk, it is because I believe that refactoring becomes even more important these days. And if in the past refactoring was not for the juniors maybe, I mean juniors would do refactoring, but usually it would be a senior doing a code review, seeing some code and then saying, okay, maybe we should fix this or that, or maybe along the life of the code base we require some refactoring, but it was driven more by seniors. And the reason is that the juniors would write the code and the seniors would work on code review and fixing the code. And today, most of the code is not written nor by seniors, neither by juniors. It is written by AI. So the juniors need to refactor the code because otherwise they would just come up with the AI code and say, okay, this is what I have. And then what is their role in the play? So we need juniors to be able to read code that they didn't write and be able to maintain it. And for better maintainability, they need to refactor it. So this is the main idea for why I believe refactoring is a trait that anyone should master from the beginning. A few words about myself. I'm a lecturer at the Academic College of Tel Aviv-Yafo, also in Tel Aviv University, co-organizer of the Tel Aviv Core CPP conference, and also a training advisor in the industry. So let's start with some code review. It's not going to be a long code snippet. It's going to be quite easy. We'll start with easy refactoring options. What do you say about that piece of code? Taken from, in this case, an exercise submitted by a student. There is a game over there with players, and we want to check something about the player, but something doesn't seem so right. I will say what I see here. Well, first I see some duplications. I mean, player at I. Now, we usually just ignore such duplications because, okay, it's easy. I believe that even these small duplications eventually hurt us. Because when we want to change something, maybe we'll change it in one place and not in the other. Better to use, I guess, a temporary variable for that, or maybe range-based for. The other thing is that negation is a bit confusing. I mean, why to negate an in or condition? I mean, it might be that someone would not read it right, or it might be that it is wrong to begin with. I would try to negate the negation. What is the player at I, not on player at I? I mean, there is some kind of use of operators overloading over there. I guess player can be casted to a Boolean, probably. Why? Do we understand what does it mean? Maybe a function with a name would do something clear. So it is not clear what we check here. And we also access a data member. I guess is alive is a data member. It's not a function call. And I prefer hiding my data members and calling functions because maybe we will change later on something in the access, validate something, write something for, we want to write to the log, whatever. And it is much harder doing that with data member access. So let's refactor it. It's a small piece of code. And still, I believe that in order to better maintain it and add later on features and bug fixes, it would be better to have this even small piece of code written in a better way. What about introducing a variable to all the player? Now, it might be that this variable can be introduced through a range-based for, but let's assume that maybe we cannot use it, or we will see. once we have a variable, it's easier in the if to just use the player. Maybe instead of accessing a member, we would call isDead as a function. isDead is better than isAlive in this case because there isn't a need for negation. And if we are creating the function and we know that the check that you want to check is whether this player is dead, why call the function isAlive if most places in code we just ask if it is dead? Or maybe provide both. I don't know, that's another question of redundancy, whether we want to provide both or not. What about the not player? Maybe better to have a function with a name. Player is not active if this is what we were actually checking. I mean, it is a bit more readable. I can understand what's going on here. Now, in case it's not active and is dead, is something that we usually check together. Maybe we can merge those into a single function. I mean, if we see in code that we call both in many cases, and usually my advice is not to refactor in the first place where you see something that you don't like so much. You say, okay, let's see if we do it in another place before I create a helper function. Maybe I need a helper function. Maybe let's wait for that. On the third time that I see that I do exactly the same thing, I say, okay, let's do the helper function. So if we see that we usually need to ask whether it is not active or dead, why not just ask whether it is not active or dead? Which, for me, seems easier. Now, one can say, okay, but what about single responsibility? I mean, single responsibility will say, you are either not active, this is one call, or dead, this is another call. And I would say, if commonly we ask this question, this is the check, then it is the single responsibility. This is what we want to check. This is the original. This is the refactored code. I would say that it is a bit more readable. Refactoring. Refactoring, the term was not created by Martin Fowler, but he is very known for this term because he wrote the book, Refactoring. And Martin Fowler, in the book and in his site, states refactoring is a discipline technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. So we don't want to change the behavior of the code. We want to keep the code as is, but with changing its structure. There is a book. This is the first edition, 2005 maybe, with a catalog of refactoring options. And I will discuss some options in this talk. A book also needs some refactoring, so he created the second edition, I think 2018. I don't like so much the picture on the second edition, because the picture on the second edition presents two bridges, an old bridge, and beside that, a new bridge. And usually when you refactor, you just refactor the old code, and the old code doesn't exist there anymore. It's not replacing the entire bridge. You just replace something. You still have the old bridge. You cannot, in a way, point on the moment in time that the old bridge became the new bridge. I mean, it's a continuous work. So, again, the idea is, okay, we want to replace something, but I would not take that metaphor of replacing one bridge with another. Refactoring is a discipline technique for restructuring an existing body of code, as we said, without changing its external behavior. How can we tell? How can we tell that we didn't change the external behavior? Because the idea is that we just want the code to be more maintainable, or easier to read, or easier to introduce a new feature. I mean, if the code is easier, then it would be easier to introduce new features. But how can we tell that we didn't change the external behavior in a way that we didn't hurt what the code was supposed to do? And the answer is quite easy: regression testing. So you cannot do refactoring without testing. Testing is essential for refactoring. I would say refactoring without testing is like a fish without a bicycle. I mean, it's a bad metaphor, but you will remember it. So whenever you say refactoring, remember the fish, the bicycle, we need testing. We need enough testing in order to have stable refactoring. I'm not going to talk about testing in this talk. There are other talks. This is a link to Google, to YouTube with CppCon and testing. And you will find there a lot of talks about testing. So why should we do refactoring, when and how? So again, from Martin Fowler, refactoring is not another word for cleaning up code. It's not that we just want the code to be clean for no specific reason. It's aimed for improving the health of the code base. So we want to support new features and future code changes. So before implementing the new changes, if we see that the code is not adapted, does not fit the new feature, it would be much easier to first do the adaptations and keep the external behavior and make sure the all tests pass, and then work on the new feature. If we do that together, if we insert the new feature or the bug fix together with the refactoring, it would be much harder to test, and we will introduce new bugs. Improve readability and maintainability. Let's assume that we go into a code base and we need to maintain it, and it's quite hard to understand. Don't feel afraid changing something if it stays the same, but written in a better way. And what should give you some confidence in doing that is that you have enough testing. And if you do not have enough testing, that add some testing in order to be more confident. Performance improvements. Performance improvements, in a way, do change the external behavior. But I would say that, yeah, but the functional tests should still be relevant. I mean, even if I change some timings and better performance, the functional test should still pass. And in many cases, we see something that is not a bug. I mean, if it is a bug, we need a bug fix, and then we actually change external behavior. But it's not a bug, it's bug prone. Something in the code, somebody can use it in the wrong way, and we want to change it in order to prevent future bugs. All those are reasons, good reasons for refactoring. And to summarize that, it is usually in order to reduce technical debt. Technical debt is code that is not written the way that we would write it, given the entire code base, which evolves, but we don't have time to change it. And when it is there, it incurs interest in the form of harder work for any additional change. So in order to make future changes much less expensive, we need to refactor once in a while. So when? On change. I mean, if we need to change the code, I mean, if we are on a certain location in code that we are not touching, do not refactor. Don't refactor stable code that you do not have any change to admit into this code. Refactor based on actual benefits. Do not refactor on subjective preferences like, oh, I prefer west const. And I know that the coding convention in my team is east const, but let's refactor. Don't do that. Don't just change things if they do not have any value. By the way, value might be admitting to the project coding conventions. So if you see a west const and the coding convention of this project is east const, let's move the const, because then the code would be more readable because it conforms with other parts of the code. Yeah, that makes sense. But do not just change style because you prefer that if others would prefer something else and there isn't any actual objective value in that. Okay, let's go back to our code. This is the more bigger snippet. We have a loop, and the loop is iterating over all players. And inside, we took the player, we did the change, and we condition now based on a function is not active or dead, which is a bit readable, more readable rather than what we had before. And still I have things that a bit bother me here. Do you see something that bothers you? I mean, my question would be here, maybe we can go with a range-based for. And the question is, why should we prefer usually a range-based for rather than looping with an index? So bounce checking, off by one errors, the need to use the index instead of just, okay, I have the object that I want to operate on. Off by one errors. Usually this is the most important issue that we want to avoid. But the problem here is that we're actually using I down below. I mean, I is being used. So I cannot just go with range-based for, but for me, if I'm going to maintain this code, again, if it is stable, I don't have to touch it, do not touch it. But if I'm going to add something into the loop, I would say, let's change the loop. I mean, let's put an index above and use a range-based for. By the way, you can initialize a size t with -1. It's valid. It is done by the language itself with string and pose. That's correct. String and pose. The end of string is -1, which is size t. Anyhow, it is valid because unsigned are allowed to overflow or underflow. Anyhow, once I do the plus plus, I start with 0. Why do I prefer to do the plus plus immediately when the loop starts? I could start it with 0 and do the plus plus at the end of the loop. There is a continue, but even if there wasn't any continue, I prefer to make sure that I will go through the plus plus. Okay, so do the plus plus at the beginning. And okay, we have now range-based for. If we are in C++20, we can do the initialization of the index inside, which has better scoping. I mean, I will not use index outside, or I will not collide with index, which might be used outside for other needs. If you are with C++23, we can use studViews enumerate, which allows you to loop with a colon and get back a tuple or a pair of index and the actual object that you want to iterate over. So I would say this, in a way, seems a bit better. And refactoring might be driven by moving to a later standard, to a more modern C++ standard. Be it moving to C+11 or moving to C+20 or 23. One can say, okay, so if inside what you do is just you filter out all the dead and not active players. You just continue, you pass them. So maybe we can put that into the loop. Maybe we can say, okay, do the for with a filter, using views filter. Sorry, I know that it is back to basics. But it is not that you have to know how to write it, but you have to know how to read it. Because you may go into such code snippet, doing ranges, if you are in C+20, and you still need to understand, okay, what's going on there? Oh, there is a lambda provided for the filter in order to filter out the players that we want to skip. And then in the loop, we just handle those that we do not want to skip. We need to filter only after the enumerate, otherwise the index would not be correct. Okay, we have this loop. Now, let's assume that we look at that and we say, oh, that is an atrocious refactoring. It was much better before. Well, the problem is that this loop, which is in a bigger function, should not be in the function to begin with. I mean, looping over all live players is quite common. It happens not only here. I mean, when I go through the code base, I see, oh, I do the same here and here and here. And the loop is exactly the same. So either it would be this loop or this one, or the previous one, there is some logic in the loop. And I wish to have this logic written only once, in one place. And we can do it quite easily with a function. Let's create a function. And the function can be, for each live player, it has a name. It gets an action, which might be a lambda, or a function pointer, or whatever the user wants to provide. And now the complexity is hidden. And the complexity might be this kind of loop, or the previous version of the loop, but it is hidden because anyhow, a loop is nice, but still can be hidden and then maintained at one place with a name, whether we like this specific implementation or not. So once we have that, handling an action would be just calling for each live player. So we call the for each live player saying, okay, we need to do something with all live players, those who are not dead or and are active. And we remember that there is a need for the index, so we ask for the index. So inside, we get in the lambda the index and the actual player that we iterated over. And now we take an action from the player, and we ask, okay, player, what is the action that we want to perform? And this piece of loop, this piece of code is implemented not in player, but in game manager, somewhere else, okay, which manages all players. And then we go over the different actions that might be requested. What do you say about this? Yeah.
Looks like it should be a switch.
It might be a switch. Yeah. I just typed it. It might be a switch, but I would say maybe even something better than a switch. I mean, we see here enums, so enums can go easily into a switch. We may go to...
Would you be able to map the enum to a function handler?
Maybe I can maybe I can map the enums into a function or a command pattern. So I would go with a command pattern saying, okay, player, you want to do something. So instead of providing me back an enum, maybe you can provide me an object, polymorphic one, inheriting from action request. And then what I have to do is to take the action, and the player can take the action from a factory. Maybe the player can return the enum if I prefer the player not to be aware of the action commands. So maybe the player would still stay with the enum, but then I will send the enum to a factory, go back and get the command, and then I would say I have now a much better and readable code. I mean, let's loop over all live players, ask for the action, and perform the action. And there is more than that in the loop, but this piece of code became, I would say, a bit easier to write and maintain. And now, you may disagree. You may say, oh, we like the loop, so I do not force you to change the loop to this one. But I would say something else. If you do see something like that, do not refactor it back to a loop. Because I do see something like, okay, a junior comes in and say, oh, I don't like this function. Let's just write the loop. There is a reason why we prefer the function, because the loop has some logic that we want to hide. There are some complexities. So we use here a comment pattern. Back to the book, the refactoring book. The refactoring book comes with a catalog of code smells and refactoring options. And the code smell is something that is bad in the code, something that, oh, I don't like it because it is bug prone. It is hard to maintain. It is not extensible. And the refactoring options are how to mitigate this issue. Why catalog? I mean, we can just look at the code and say, oh, I don't like that, let's do that. Why do we need a book? So a catalog provides shared language, very similar to design patterns. It was in the era of let's do catalogs. And Then when we see a code smell, it is quite easy to go to the established refactoring options without thinking too much. It's like a chess opening book. When you start a chess game, you will never see a professional chess player on our first move thinking, what should I do? Oh, this guy, they did E2 to E4. What should I do now? No, there is like, automatically we know the first 2, 3, 4 moves. Same here with, for this one, there are some options that we know what we can do. Makes problem detection systematic and repeatable. Again, because we know what are the options. Provides actionable remedies. Again, we know this is the case, this is how to solve it. And it supports education, onboarding, and code reviews because we have the common language, we know how to point at something, and it is already established. It's a living catalog. It's not a finished book. I mean, the book is finished. But there are other code smells that are not in the book. If it is not in the book, it doesn't mean that it is good. There are code smells that are not in the book, and there are refactorings that are not in the book. Okay? And I will discuss a few. And software practices evolve, so we will see new issues and new mitigations. Let's go through partial list of code smells and mitigations that appear in the book. We will not cover all, okay? And you may want to go later on, achieve the book and go through that, or I will tell you other options, even though I do recommend having your hand on the book. Long method. I guess this is the most common. Long method. Do you have long methods? We do have long methods. Usually we have long methods because it is much easier to write a long method. I mean, we have all the information inside. Why should we go other way? I mean, it's all inside. But eventually, long methods are harder to maintain and tend to be more bug prone because there are too many moving parts in this function. If there is a small thing, it's harder to accommodate bugs into a small thing. It's much easier to put new bugs in a big function. So common refactorings for a long method. Extract method. Take a portion of the big method and extract it into a different one. Then, of course, you would have to pass arguments. That's OK. Now, the function would not be able to mutate all the local variables that we have in the big function, only those that we send to the new one. And if you send it by value, then it wouldn't be able to mitigate those as well. So I'm protecting the bigger function in a certain location where, now we only need to do this. And this should not interfere with anything else in the bigger function. Less room for bugs. Replace temp with query. In some cases, we create a temporary variable, a local variable in the function. Then we take some result from a function. Then later on, we use this result. I like it. I prefer using local variables for that. By the way, replace temp with query. There is a refactoring entry in the refactoring book. And there is another one saying replace query with a temp. I mean, refactoring in some cases, you can do that, you can do that. In some cases, do this. But in other cases, maybe it's better to do this. When should we replace, you just call a function and take the result and do something? That's not good. Better put it in a variable and then use the variable. When do we do that? When should we do that? You call a function and say, but there is a replace temp with query. I'm using the query without using a local variable because it is like shorter. No, here I would prefer you to use the local variable with a name because the function name is misleading or not clear, and I want to put a name on, or the function returns something without measurement units because we're using weak types instead of strong types, and I want either in my name to say something about the measurement unit. Better move to strong types. So it might be that I want something there. By the way, what is the tell? What is the hint that, better use the local variable here instead of just using the result from the function immediately? What is the hint for that? That we have there a comment. If we have a comment saying, we do this and that. I say, why a comment? Why not having a variable saying the same thing? And this is a refactoring option in the book. But here, if the method is too long, in some cases we say we do not need this local variable because the function name is enough. So maybe you can take this function name, put it in the if, instead of calling the function, putting it in the local variable, and then using the local variable, in some cases even not immediately after calling the function. Let's assume that there are 5 lines in between, and we already forgot what we were doing, and maybe even introducing a bug in between, changing the value, which maybe we shouldn't. So maybe replace temp with query, maybe the other way around in some cases. Replace method with a method object. In some cases, the thing that we're doing inside is not enough just to take it into another method. It is a complicated thing that is being done there. Maybe you need a class, then create an object, then call a few functions on this object. We are using object-oriented programming, right? Decompose conditional. You have complicated conditions, and you want to keep that in the function. Maybe you want to put it outside, but let's assume you want to keep it in the function. Then break the complex condition into smaller, well-named methods. Again, okay, use the method, and the condition would become clearer. Do you have an example? Can you think about examples of things that we mentioned here? We had it at the beginning of the talk. Do you remember that one? It's part of a bigger function. And if I take that and applying extract method, I get a method that is the loop. And if I replace method with a method object, I create the action, and I call execute on the action. It's an object. And I prefer an object rather than a switch, then calling the proper function. Oh, why not use an object and polymorphism to find the proper operation that I want to apply? So we used it without maybe going through the catalog. And that's okay, by the way. If you do proper refactoring and you do not remember the names from the catalog, it is still fine. Don't feel bad with that. Long parameter list. Do you have functions that get too many arguments? Yeah, it happens. I mean, to begin with, the function only took 3. But then we needed something else, and it became 7, 9, 12. 12 is too much. Let's do something. Okay, we should have stopped like at about 5. But too many arguments. Now, the problem with too many arguments is that it is harder for both the caller and the function maintainer. And it will be bug-prone on both sides. I may send the arguments in the wrong order. I may assume something about an argument. Oh, this was not that one. I should use this one. More arguments, more room for troubles. What can be done? What should we do? We can create a struct. Common refactorings we can do. Introduce parameter object. Instead of taking these 5 arguments, maybe all these 5 arguments can be packed into a struct or a class. Preserve all object. Maybe there was a class there. And instead of sending the object, we just unpacked it. We just took the actual data from the object in order to send that instead of sending the object itself. So why not send the object itself? What do you say? I will discuss that in a moment, because sending the object itself is not always the right thing to do. But that is a refactoring option in the book. Replace parameter with a method. Now, replace parameter with a method means, okay, you can get this value inside the function instead of me sending you the value. I would say, I'm not sure that I want the function to call the method. I want to call the method because the responsibility of achieving the value should be outside in this case. Okay, it might not be the right fit, but it is an option. I mean, why should you send this one? The function can achieve it by itself, then we omit one argument. I'm not sure that would be for the best, because in a way, it makes the function stateful instead of stateless maybe, and instead of being more generic, we will discuss it in a moment. So I want to check these two and say be careful with those. because what about readable object? It might be a code smell by itself. Why?
Because you're letting the function or whatever deal with the whole object. It might change.
I'm letting the function, thank you, Rob, I'm letting the function be aware of things that it shouldn't be aware of. Do we call that? We are breaking encapsulation, we are creating tight coupling, so it helps in encapsulation and decoupling. Now, preservable object is in the book. I would not recommend always doing that. I mean, in some cases we say, yeah, it's okay, these two are tightly coupled anyhow, so why not just pass the object? We're using the object elsewhere, just pass the object. But in some cases, you should not know how the object is built, or you should not speak with this object, because once I pass you the object, it's not that you can use only the arguments that I wanted to send you. You can actually use everything. And for that, we have Tony Van Hert's koan. A koan is a short story with a moral, okay? If you do not know Tony Van Hert, first thing after this talk, go and find talks by Tony Van Hert in YouTube. I don't think that he's in CppCon this year. He was in CPP North a few months ago. Great speaker, great talks. This is from his Twitter account. He used the same example in one of his talks. Let's go through the koan, okay? A master and his dog. Master, the student says, I'm honored by your visit. So the student is in his backyard and he sees the master going by and he thinks that the master is paying him a visit. So he's saying, oh, I'm honored by your visit. And the master was not actually coming to visit the student, but he doesn't say that. He says, I was out walking my dog. And then the master sees that the student is coding. And he says, your function, why does it take big common struct instead of just x and y? I mean, you have a function, and instead of passing to the function x and y, you pass big common struct. So the student answers, big common struct is where we keep x and y, master. Bark, the dog barks. He's hungry, the master says. Shall I prepare him food? The student asks. No, just open the fridge. Let him take what he wants. That's the message. Did you get it? Why shouldn't we pass big common struct? Why shouldn't we pass the all object? Because the other side would use it. And by using it, it will be usually, or at a certain point of time, abusing it. Using it not in the sense that we wanted it to be used. So passing the entire object is not the right thing to do in all cases. In some cases, maybe it is. But it would make the, do you remember the code smell? The long argument list a bit shorter. Okay, this is a link to another talk of mine discussing this koan and hiding your implementation details, keeping abstractions, keeping decoupling, okay? You can watch it later. What about replace parameter with method? So again, if it is, okay, I'm not sending anything, the function would call the method inside, I'm a bit worried about that because, again, I'm putting now a state into the function. The state should know something about a method. In some cases, you say, yeah, this is the responsibility of the method. But in other cases, you say, no, I want to keep things stateless and keep the responsibility on the caller. So instead of asking the called function to achieve the proper information, I can do something else. I can still send something which is not the arguments, but is an interface. Saying, okay, you can achieve the information. Maybe you need to achieve things. It's quite similar to passing an object. It's passing an interface, which would be a base class for something, and we call this dependency injection. Okay, this is what you have to use in order to retrieve some information. I would not retrieve the information for you, but I will give you the thing that can retrieve the information, okay? And it is quite usable for testing. So dependency injection also can shorten the long list of arguments usually when this specific interface can provide more than one single argument. Oh, it will provide this and this and this. Large class. This is another problem. Do you have large classes? Usually we do. So a class that has grown too big, usually they start small, taking on too many responsibilities and becoming hard to maintain and hard to reuse. So common refactorings would be extract class. There are some things in the class that should move to another class, and then I can use the other class in my class. I mean, take x and y, create point, and hold the point. Do you see my point? Extract subclass. Maybe part of the responsibility can go to a subclass of mine, and then the user can use the subclass or my class. Or extract superclass, which is quite similar, but which type do you want to use, me or replace data value with the object? Replace data value with object is not, it's quite similar to the first one. The difference is that in some cases we have an int or a simple string and say, oh, this string represents a person. In the class, we retrieve the person and do things. So why not just keep the person? Or instead of the int, keep the thing that the int represents or a reference to that. So just take one primitive type or one field or enum and replace that with the actual thing that you want to manage. And in some places, it will make the class easier to maintain and with less responsibilities, because instead of taking the primitive and doing things with the primitive, I have an object that knows how to do stuff. Comments. Comments are good, right? Not necessarily. In some cases, comments might be a code smell. So comments can be a code smell if better coding would remove the need for redundant documentation. In some cases, you say, why should you tell me that? Why shouldn't the code tell that? And code telling something is much better than comments saying the same thing, because code is being compiled. Comments are not. So when code changes, the message that you want to expose changes with the code. The documentation do not. And you still have old documentation saying something, and you go to the code, oh, it's not what is going on there. But maybe it is. Let's keep it. By the way, do not. If you said that the comment is wrong, refactor the comment or remove it. How can we remove comments? So common refactoring, extract method. In some cases, we are doing something, and we explain above what we're doing. What is the best way to explain something? Give it a name. Make it a function. Oh, and it also helps with reducing the size of the function. Yeah, do that. Give it a name. And if I say a comment, maybe all the things that I do below should be in a function. Introduce assertions. In some cases, the documentation says, oh, we assume here this and that. Why do you assume that? Oh, because the documentation says so. Maybe it would be better to assume it with an assert or an if and an exception. If you go back to Herb's talk on contracts from yesterday, in some cases, it's an exception because, oh, it may happen. In some cases, it's an assert because, no, it shouldn't happen. It's a bug that I cannot continue if it happens. So either assert, exceptions, or contracts if you are in C++ 26. Switch statements and complex conditions. I mean, we do want switches at some places, but not all over the place. And we want to hide our switch, to put it inside a factory, for example. Yeah, the factory can have a switch because we want to see which enum we got, and then we create the actual object, and then you go with the object and polymorphism. And the same thing goes with complex conditions. We want to hide them and then give them a name. And then things are much more maintainable and easy to read. So complex conditional structures may become long and complicated to maintain, violating the open-close principle of it should be easy to extend our system and hard to abuse it, to use it incorrectly. And it makes the code hard to extend. Let's assume that I take the action and then I have a switch of what should I do according to the enum of the action. Each new action should require a new entry in the switch case. I want generic code, getting the action, doing something, polymorphism and classes. So replace conditional with polymorphism. We do that. But we should do that also with old code, not only with new code that we are writing now. And doing it with old code means refactoring. And in order to do it for old code, refactoring requires testing. Replace type code with state strategy. It might be that we hold inside the class something that tells us what our state is. And then we are going to do something, we query the enum or the int, and then we do what we want to do. Why not hold an object, state pattern, or strategy? Do you know the difference between state and strategy? Because they are quite the same. I hold an object, and when I want to do something related to this object, I ask the object to do the operation. So state pattern, we use the term state pattern when this object is part of the bigger object state. I mean, if you change the state, I'm not the same thing. Oh, you changed my state, I'm not the exact same thing. Strategy is I can do things in several different ways. I can do it BFS or DFS. Does it actually change myself if I change some internal behavior for efficiency or for bigger map you do that, for smaller map you do? No, I'm the same. So my advice is if you actually want to answer the question whether it is state or strategy, think about there is a function in the class that if you implement that, state would be inside, considered, and strategy would not. And that is equality operator. I mean, if I get two objects, should I check this field for equality? If the answer is yes, you are using a state pattern. It's part of your state. If not, oh, that's a strategy. I mean, if two objects are the same for all other means and are not the same for this field only, and it doesn't bother me, I'm saying, oh, they're the same, then that's a strategy, but it's mostly terminology. Anyhow, replacing a member, a simple member, with a strategy would make a switch disappear in most cases. Introduce a null object. In some cases, we want to check, oh, are you null? Now, it doesn't have to be always null. It might be, are you open, are you closed? It might be that, okay, instead of asking, why not just do the operation? And if it is a null, instead of holding null, hold an object that when you call the operation, it would just ignore the operation. That's it. Do nothing. Now, in some cases, people say, no, but it would be costly. No, it would not. It's an inline function. I mean, holding a null PTR, holding an object that doesn't have any fields, it should be the same eventually. And in some cases, you say, you know what? If you do call the function, I want to log. Oh, so instead of having the if and then logging, just call the function. Oh, the null option, the null case, it is being handled. You're having a null object, an object that represents the null case. And again, it will remove the need for ifs. By the way, another example is when you implement linked list and you use dummies for the linked list. If you know that, using dummies, avoid the need to check whether the head or the tail have changed. So in some cases, you add some data, you pay with storage, which is it's only 2 nodes. And then you do not have to check whether head or tail have changed. And again, it reduces the complexity of redundant if statements. The book itself has 22 code smells and 72 refactorings. We will not go through all of them. I don't ask you to know them by heart because instead of seeing some code and asking yourself, what should we do here, you can, nowadays, use AI. So I took the code to AI and asked it, okay, this is the code. What are the code smells? And I urge you to do the same with your code. Don't ask AI to refactor the code. Not now, maybe in a year, maybe in 2 years. Today, it will not work quite well, but you can ask, what are the code smells? And this is what I got. A few answers, all are quite good, okay? And then the AI and a few more notes. All are good. And then they ask me, do you want me to refactor that? I asked him, can you tell me, using the refactoring terminology of the book? And he came with, this is how it is called in the book. I proposed, do you want me to refactor that? And I said, yes. And I got something not so good. So the refactoring itself, in some cases, would not be the best. I would say, for now, okay? But helping you, thinking about what are the code smells? What are the possible refactorings? Don't do that. I mean, just propose. I will decide whether it is good or not. Additional few C++ refactorings, which are not in the book. By the way, the book is mostly speaking about Java. When there is an example, when there is they thought about, but C++ can use some refactorings as well. Move weak types to strong types. Don't use types as just primitive. There is measurement unit. I mean meters, seconds. Satellites may crash on Mars if you don't do that. Move from user allocations to library allocations. Do not use allocations in your code. You can see the old code above and the new code below. In the old code, I allocate. Now, there is something in between, and there is a link to a talk that I gave on the full path to go through. I have allocations. Oh, I still have allocations, but they are hidden. The path goes through, I'm using smart pointers. And in the middle, the user sees the smart pointers. And I recommend having the smart pointers as an internal implementation detail. Okay, it's not something that you should be aware of, that I'm holding a smart pointer inside to all the math expression. I don't want you to allocate. I will allocate. I don't want you to be aware of the fact that I'm holding a smart pointer inside. Just create something. I will do the allocation inside. Move from pointers and references to values. Value semantics, if you look for value semantics, you will find talks about that. Simplifies ownership, reduces risks of null and dangling resources. Do you have an example of moving from pointers to value semantics? It's the previous one, same thing. Moving from pointers, the pointer is hidden inside, but I'm working in this example with sum, and sum is a value, an object, not a pointer to an object. The polymorphism is a bit hidden inside. And again, there is a link to a talk which goes through this path. Prefer standard algorithms over row loops. Sean Parent, 2013, famous talk. No row loops. Now, I like row loops. I mean, I write row loops. And you may like them as well. And I'm not saying every row loop should become a call to a standard library algorithm. There is a talk by Sander on Friday about performance issues. In some cases, maybe we would prefer the row loop, but do not take a call to standard algorithm and say, oh, I prefer a row loop and refactor it to a row loop. Never do that. I mean, if you see a call to function, something that is declarative, a call to an algorithm, don't say, why not a row loop? Let's move it to a row loop. Don't do that. And if in some cases you do want to move from a row loop to a standard algorithm, Sean Parent will confirm. Avoid macros if possible. Use RII. Are you still locking and unlocking? Stop doing that. I mean, when I say stop doing that, I don't mean only stop doing that. I mean, if you see that in code that you currently maintain, refactor it. And when I talk about RII, I mean constructor, distractor. The distractor should be the tool to unlock, to release memory, to close the database connection, etc. Otherwise, I may have leaks. And we have an established common pattern, which is resource acquisition is initialization, acronym RII. Let's summarize. Continuous refactoring is required. Otherwise, our code would get technical debt. We need to do that. And I would say we need to do that even now more than in the past because the code is not getting better with AI. Refactor code that are actively working on do not touch code that shouldn't be touched just because, oh, I can refactor that to be, nobody is touching that. There isn't any bug fix there. There isn't any need to maintain it. I mean, at a certain point of time, maybe you will be required to maintain that. So then, coding with AI, code quality and productivity doesn't necessarily improve. I have here 2 links worth going through. A key message. It's the programmer's responsibility to own the code, to understand what's going on there, and maintain the quality, because there is research already that code quality with AI is going down. More duplications, less conceptual integrity. I mean, we want conceptual integrity. We look at the code and we say, oh, that is good. And we get something that works. But when we look inside, we say, oh, no. And then that is our responsibility to make it better, because otherwise it will become a big ball of mud. Refactor for a clear reason, not just by intuition. I mean, what do we achieve in this refactoring move? This is the question. And once we have an answer, then we have a map. We do not go for the travel without a map, okay? And we check occasionally that we are on spot on the map by testing. So we need small, incremental, testable changes to make sure that we are on the map. You may use AI for refactoring, but probably just as an helper tool, not as do the refactoring. I'm not taking a look, because you will get worse code than before, in some cases, okay? And again, this is my experience, and you read that. It's not only my personal experience. Relying only on AI to refactor your code probably will, true for September 2025, maybe tomorrow it will be perfect, or in a year from now, result with messy code that still needs refactoring. I mean, in some cases, you are in a loop. I had an example where I wanted 2 classes to share a base class. So I asked the AI to do that for me. And the AI created the base class, but it didn't use the right functions in the base class. I mean, still I had 2 derived classes which do not use the proper functions from the base. So I asked the AI to fix that. And I got some fix, but then I got something broken. I mean, the code compiles. Usually some magic goes there, and it works, but not the way that I wanted. And eventually, after 1 hour, I realized that I could do that in 10 minutes. So in some cases, it's more productive just doing it yourself when you realize what you want to do. That is for now. So thank you. And if you have any questions, I'm here for answers if I have. There is a mic if you want.
To go back to the, one of the very first slide, the long code example that we refactored, and showed how, some things. So, I mean, it's an impressive refactoring. You turned it into a thing where the loop itself is only filtering live players, and did the command pattern and all that. But those also imply changes at other places in the source base, right? It wouldn't just be in this one source file. And isn't there kind of a risk there? Now you're making a change that's distributed across several places in the source space. I work with people who would be like, that's a code. No, you shouldn't be changing places all over the code. How do we know that this doesn't have other effects? That's sort of a anxiety-inducing in itself.
That's a great question. Yesterday there was a talk by Andy Soffer, tackling refactoring as well, and he presented a graph, a chart of refactoring that are local and refactoring that has a networking effect, networking in the sense that affects other code pods, and you should do both. But when you do a local thing, you know the risks and you know what you're doing. When you do the more broad thing, then you need to communicate to make sure that others, and to have access to the code base. You cannot do that if there is an external user that you do not control and you want to refactor, you must still preserve the old function. So it might be a good thing to preserve the old function, maybe add a deprecate annotation or comment above that saying, okay, I have to keep that for these users, but if you're a new user, use this one. I would go with this approach, but if you can eventually get rid of the old one, again, you need access to the code base, you need communication with other users, don't piss anyone off. In this case, I would say this is a local change. Why this is a local change? Because it wasn't a big function that had a loop, and I'm taking the loop and using another function. Now, I can use the same function also in all other uses of I have to iterate on all live players. I don't have to do it immediately. I just have the function, use it here, then maybe advertise to the entire project. Oh, yeah, okay, we have a new function, maybe you want to use it.
Okay, thank you.
Thank you. I think that we have time for one last question.
Quick one.
Thanks.
Thank you very much. It was excellent. What are your thoughts on short-circuiting when you have like at the beginning with a function, if, return? And would you prefer that over if, return, else, if, return, else, if, return?
So the question is, in the beginning of the function, we want to check something and then early return, okay? Because the arguments are not okay. There are those who prefer early return. There are those who prefer to start with the actual thing, like an if, and then the return would be at the end. It may have performance implications, even though you can use likely and unlikely.
For code clarity only.
So for clarity, I go with early return.
Okay.
Usually I want to take off from my mind all the error cases and then focus on, okay, now I know that I'm ready for the function. This is my approach, but I'm okay with other approaches. Usually I would not refactor that. This is an example of something that I would not refactor just because this is my personal choice. Because other choices are okay as well.
Quick one more? Yes? So small functions, I am in big favor of small functions, but sometimes they can create cognitive overload. Just saying, so we should use common sense.
There is a trade-off, always, always. I mean, if we have thousands of very small functions that only do a very, very small thing, we can say, why do you need this function? Why not just, and in some cases, you will not create these small functions.
Are you familiar with the book called The Philosophy of Software Design?
Sounds familiar.
By John Ostrust, who is the creator of Raft protocol.
And you mentioned that because?
Because he argues with Uncle Bob like viciously, and he talks about small functions and the depthness of the classes.
So I will tell you something about small classes. This would be the last comment. Small functions, small classes. I strongly believe in stateless functions. Anything that can be stateless, start with the stateless. And in many cases, we have stateful things that should be stateless. Stateless is much easier to test, much easier to maintain. And in every framework, every big project, there are a lot of things that can become stateless. So every big stateful thing has inside a few dozens of stateless operations that should and can be implemented as stateless, even if they take a few arguments or an object that hides those arguments and just do the work without they do not rely on anything external. They take everything that they need, including dependency injection. Maybe they do take some object that they will use in order to retrieve some data. It is still stateless. Thank you all. Thank you very much. I'm here for discussions and questions if you have.